We are now starting to talk about model diagnostics in a sense of checking whether the assumptions of the model are met. So there are 5 different diagnostics we will talk about in turn, but for now we'll first start with the assumptions. All right, if the assumptions are incorrect, then statistical tests are not meaningful. That is true. So here are some assumptions. Constant variance. The residuals, the true residuals, are Gaussian distributed with variance sigma squared. And the sigma does not depend on x, so it's constant. It doesn't change. The Gaussian distribution is an assumption, of course. And then the linearity of the model, its linear regression, is an assumption. And the independence of the residuals is also an assumption. And it's the true residuals that are independent, not the estimated ones. We do not try to prove assumptions. What we do instead is we look for trouble. We falsify expected behavior. So we look like what we think we should be seeing, and then we see something that's not consistent, and then we cry foul. It doesn't work for us, assumption not met. So before we now go into the first diagnostic, we'll talk a little bit more about estimated versus true residuals. Part of the reason is that estimated residuals are used a lot in these diagnostic plots. So the true residuals are supposed to be independent from one another. So if I write it as a vector, here's one residual, here's a vector. It's sigma squared times I, and the off diagonal on the identity matrix are 0, signifying independence. We never know the true residuals because we never know the true betas. Because if we knew the functional relationship, we wouldn't be doing any estimate. We can estimate beta and then get the predicted value of y, and then the difference is the residuals. So we can estimate the residuals, so we get the residuals, the estimated ones, but we don't have the true ones. Now, for the estimated residuals, so y minus the estimated y, we get this term, details on the next slide. And I is the identity matrix, and this minus h represents the departure from independence. H is the hat matrix. We had briefly seen it before. And the variance based on this then is sigma squared times I minus h. And as I said, h is the departure from independence. It's not a lot, it's just a little bit dependent. And you can see the calculations here, how we get from up here to down there. I will not go through that one by one because it's too boring. You can look at that by yourself.